Good day, my fellow learners. Today we are going to talk about the Michaelis menten. Sorry about that. The Michaelis menten equation. There is a general reaction that states that enzyme plus substrate give us enzyme substrate complex. An enzyme substrate complex will break down to give us enzyme plus product. Enzyme substrate can equally break down to give us enzyme and the substrate. There is a steady state assumption that states that the rate of formation is equals to the rate of breakdown. So to prove the steady state assumption, a steady state assumption, we have to prove it from here. Let's call the rate at which enzymes plus substrate forms enzyme substrate complex K1, and the rate at which enzyme substrate complex break down to give us enzyme and substrate K minus 1, and the rate at which enzyme substrate complex break down to give us enzyme and product K2. So let's put it in a single equation. K1 enzyme substrate equals to K minus 1 enzyme substrate complex plus K2 enzyme substrate complex. Let's look at some of the derivative of the Michaelis menten equation. E total equals to enzyme substrate complex plus enzyme. The initial velocity, which is V naught, is equals to K2 times enzyme substrate complex, and your maximum velocity is equals to K2 times enzyme total, and your Km, which is the Michaelis menten constant, is equals to K minus 1 plus K2 all over K1. So for your enzyme total, making E the subject of the formula, we take this E total to this other side. We have E total equals to enzyme total minus enzyme substrate. So we have to represent this to this, since your E is equals to E enzyme total to minus enzyme substrate complex. So K1 is equals to enzyme total minus enzyme substrate times substrate equals to K minus 1 plus K2 times enzyme substrate. So we have to bring this here and bring this here. So we are getting K1 times enzyme total minus K1 enzyme substrate complex times substrate equals to K minus 1 enzyme substrate complex plus K2 enzyme substrate complex equals to, since they are like terms, you just choose enzyme substrate complex K minus 1 plus K2. Same to this other side, K minus 1 enzyme total enzyme substrate minus enzyme substrate complex and substrate. So we can divide both sides by K1. and this will cancel this. So this becomes your Kn. So we are going to represent it here. Enzyme total substrate minus enzyme substrate complex substrate equals to your enzyme substrate complex and your Kn. So we take the enzyme substrate and your substrate to this other side. So we are having enzyme total substrate equals to enzyme substrate complex Kn minus enzyme substrate complex substrate. So since there are like terms here, we have to bring one of it outside. Enzyme substrate complex Kn minus, this is plus rather. So enzyme total substrate. So let's divide both sides by Kn plus substrate. This will cancel this, and your Kn, your enzyme substrate complex will be like this. Your enzyme substrate complex will be equals to enzyme total substrate all over your Kn plus your substrate. There are some derivatives that say your initial velocity is equals to K2 times your enzyme substrate complex. When you divide both sides by K2, this will cancel this, and your ES becomes V naught all over K2. So let's represent your ES as V naught all over K2. V naught all over K2. So we have to divide both sides by K2. We have to multiply rather, which is K2 minus 1 all over 1, I mean 2, and K2 all over 1. And this will cancel this out. And your E total times substrate will multiply by this, and this will multiply by this. So we are getting V naught equals to K2 enzyme total substrate all over Kn plus substrate. Since your V mass is equals to K2 times E total, V mass equals to K2 times E total. So this becomes your V mass. So V naught equals to V mass substrate all over Kn plus substrate. And this becomes your Michaelis menten equation. In order to invert it to the Lineweaver plot, you bring this to the upside and bring this down. So it becomes 1 all over V naught equals to Kn plus substrate all over V mass substrate. So 1 all over V naught is equals to Kn all over V V mass plus X all over V max, and this, your substrate will cancel the substrate, and what is left is 1 all over V naught equals to Km all over V mass 1 all over plus 1 all over V mass. And this becomes your Y equals to M X plus C. So this is how we got to the Line-Riverburg plot and how we derive the Michaelis-Menten equation. This Michaelis-Menten equation is very, very important when it comes to enzyme kinetics. And these are the derivatives. So E total plus for enzyme, your V naught, this is the initial velocity, your V mass, which is the maximum velocity, your Km, which is the Michaelis-Menten constant. These are the derivatives to note when it comes to deriving the Michaelis-Menten equation. Thank you for listening. I hope it all makes sense.